Thanks for coming, everyone. So today, that's a really long title, I know, but so let's boil it down a little bit. First, I'll introduce myself. I'm Sean Horn. I work in the customer support area of Chef. I've been here for 6 years, been in the business for 18 years, started out on HPUX, you know, nice hardware, weird software, right? So that's where I'm coming from. And what we're looking at here is a thing I'm calling a habitat transducer, but that just sounds cool. What it really is it's just plain old Postgres, like everybody uses, Redis. That's fancy, right? So the Redis is normal, the Postgres is normal, the Redis is a little bit fancy. It's got the 4.x release which has the streaming module in it. Because what we're building here, what I'm about to show after we go over a little bit of backstory, what I'm about to show is it's just a messaging pipeline. And we have producers that produce into the pipeline and consumers that pull off the pipeline. You know, as opposed to a queue, though, it's like a log, like in the Kafka sense. So stuff doesn't ever really disappear. It's kind of immutable. So let's go. That's my intro. So a couple concepts, and then we'll go through those in more detail in a few. So what we're looking at here is like oh, my slides. Let's do it this way. My slides are out of order. So probably most of you in this room know what we're talking about here. It's another blasted acronym for something databases do. Guarantees that databases can make about data, right? And so here's a pretty trippy screen. I actually wrote this talk for San Francisco in the 60s, right? But what happened was I showed up in Chicago. But it's fine. It's fine. The people in pizza are great. I don't mind it at all. So really we're just saying, I got jokes, man. Atomicity, consistency, isolation, durability. That's a SQL database, right? That's why we want those guarantees. In this systems case, we want those guarantees because we're going to use them to hide stage data from the output of the pipeline. So the database is kind of our staging area. The Postgres database is kind of our staging area. The Redis streaming area is our system of record. We won't those, once they're present, they're in a sense committed. And so that's what's going on with the like data side of things. And back on the other slide, here's the way that we're going to guarantee that things only happen once, as much as we can guarantee that. So maybe you think this definition is wrong. All powerful, right? No. Is that right? That's not right, right? That's a funny little joke, right? Maybe SE Linux is all powerful. Maybe something else is, but. Idempotence, like if we boil it down, idempotence says if I make 2 submissions of a record and those records have primary keys so that I can distinguish them, if I get 2 submissions in a row for that same record with the primary key the same, just ignore the last one. Ignore all but the first one, in other words, right? And you hear idempotence or convergence all the time at Chef, and so I had to include it. It's kind of a requirement, right? We like to use that word. So here's the cool part. The Redis streaming mechanism has properties in it whereby you can be imprecise about where do I want to read that stream from. You can say, read it from the beginning to the current end, which is now, right? The timestamp now. And so now is always marching forward, and the records are always growing on that stream. And so those properties that it allows you to use, I used in this application system. The goal overall was to use Habitat and then build an application system on top of it. So it's not the star of the show in this case. It's the little set of apps that are the star of the show. What we've got there is a a simulator that simulates records being submitted to this system. We've got a streamer, which is the actual part that goes, hey, is it time for this staged record to be input into the permanent place, which is Redis streams. So it goes along and checks back and does that. Then the consumers come along and they go, oh, cool, I see this new permanent data, I'm gonna go get some. And then the output of the consuming portion of the system is a little graphical display. And let's take a look at that. It's not the wrap up, actually. Like, this is the demo. So let me switch over. Let's see what we got here. Can everyone see this? Command plus. That made the window bigger. How about now? All right. Okay, so this little script I've got here, it does the whole thing. I have the databases running. I have the databases running over here. So they're going, but I'm about to empty them out. I didn't want to waste time with starting up things. So I'll probably stop as we go through this so that I can explain. So right here, truncate table. So I just dropped everything in Postgres, and I also dropped everything out of Redis. So both of those data stores are completely clear. I start up several kinds of processes here. I'll go through them real quick. The API is there's an API sitting there. The simulator makes requests to that API. The API then stages the records in Postgres. So that's how far we get with an API and that's how far we get with the API. So then we have a couple more types of processes. We have multiple consumers which have identical code. So they're both consuming from that same stream. And then we have the streamer, which is, like I said before, is moving the records from the ephemeral side of the system to the permanent side of the system. And the simulator is cool. The simulator is actually injecting failures into the system as it runs. So I've explained all of the process types, and I'll look around here. So this is all random, so I'll look around here and find a cool part. So here's a crash right here. So the system takes batches of these messages and drops them. It streams them into Redis, right? But sometimes a crash is injected, and so it has to start all over again. So the consumers are also checkpointing and saving their state as they go along, so that they can restart and not break. So let's see if we see another. Oh, right here. So this is the idempotency property in action, and ignore that distant stuff. This is working. That's an artifact. This skipped record, that's the idempotency in action, right? So we said, oh, I already saw this one. It's in my memory. Forget about it. I'll ignore it every time I see it again. So let's scroll back up and see what we're looking at here. So consumed record ID number 1, right? So both consumers should have done that, and so on until we get to record number 10. Record number 10 right here. So both consumers got all 10 records just for this demo. It could have been an infinite number of records. So now everybody went to sleep because there's no more work for them to do. I said simulate 10 records and stop, right? So even though there are only 10 records, there's like the injected failure rate is like 20% or something. So they are failing and they are recovering from those failures as the system goes along. And so just pretend like this is part of the same system. It's reading the data from the stream side of the system. It's just a little clunky. Okay, so here's the sad part. I was fooling around and I broke it, but from what I've explained with the streaming system, I think you can see that 10 records got in the system. There were duplicates on that stream that the consumers were able to ignore because they knew, oh, I've seen that before, I'm cool. So the system is perfectly consistent. If this display were working properly, it would be the Habicat's little sash turns color, right? And it's the color that was embedded in the JSON document in each message, 10 messages, right? And so the point of the numbers was, here's a history of the messages that we saw as we changed the Habitat guy's colors, right? So I can, yeah, it's really clunky, I'm sorry about that. Can you even see that? Right, so imagine as if that history were there the whole time, because it is there in the data store. Because this is reading from the data store. See, it's reloading. I screwed it up. So once again, sorry about that. But hopefully I explained it enough so you can see exactly what's going on. So let's go down here. So the reload is changing the stroke style back to black. It's lame. But let's see. Oh, remember that green? Remember that green? Both of these consumers, so the first entry on Habitat A, I should say, the first entry was this exact color of green. Another fancy part that I didn't show you, I don't know if I have time for code. It's kind of boring too. But another part that I didn't show you is that we are taking a simulated color and then adding to it, so that if there were any mishap in the whole messaging apparatus, you'd get like double stores, and the colors would go off the they would overflow. Like RGB has 255, right? That's the max. The colors would be overflowing that if any of the messaging were screwed up. So these are consistent. See, there's that lavender again. This is kind of maybe I should have thought about vision issues, but I hope everyone can see this. I can say the colors at least, right? So that is kind of my talk. I want it to be more impressive with this little thing, but I hope that you can see what I'm going after here. And if anyone has any questions about other parts of the system, I could dig around in various parts of the code if anyone wants to see it. Like maybe would anyone want to see the failure injection? Because that's pretty rad. To see that it was actually doing such a horrible thing to the system, but was able to survive. Let's check it. Yeah. Okay. So number consumed. So run once is run the consumer once, right? Randomly inject a 20% failure rate. And we did run into one of those during our run. Let's look, simulated crash error, right? So we actually Ruby kill the process so that it just it has to start over again. It can't survive that. Here's some of the magic about checkpoints and keeping track of where are we in playing with Postgres and with Redis as we're moving along. So let's see. Let's look at something. Yeah. So it saves its checkpoints, it saves its state, and then it's out of there, and it goes back around. It goes back around to check again. Sleeping a lot. Let's go look at this one more time to make sure I didn't miss anything interesting. Crash simulated. Yeah, no, that's it. So it is able to recover from crashes, and those crashes would have injected those crashes would have injected extra records of the same ID in the stream. And so that's why it's important and impressive that, let's go look and find it again. Already consumed this habitat color ID, so it knew, and it can protect itself from that. So I could answer questions if anyone has some now. So I guess no more questions. I guess I can wrap up. So, you know, what we saw here was kind of a collection of various little cool things. I think that habitat offers a lot of properties that would fit in well with a system like this and vice versa, right? You can't just say, oh, I've got leader follower, now I'm done, right? Like if you want a truly reliable system, you have to go beyond that. The application has to be aware of the data store in reality if you want to have really high uptime. And you know, fault tolerance as well. Like high uptime is meaningless if all your data is corrupted, right? It doesn't matter. So this takes care of that portion of the total issue. So with that, thanks a lot again, everyone, for coming. I appreciate it. And I'll see you later on, I hope.